Okay, G. Good morning, students, and welcome to my this channel live lecture and other live lecture that is the atomic structures. So, in the first lecture of the chapter two, we discuss about different types of the atomic particles, means subatomic particles, and also what are the history of the atom. Now we will talk about what are the models of atomic structure, who will present such type of models, and rather than that, after that we talk about the atomic number and mass number. So it is very exciting lecture. So hopefully you students join me. So first of all, we talk about the Rutherford's gold foil experiment. He performed an experiment that is called the Rutherford Goldfoil experiment. Okay, the Rutherford basically he discovered the nucleus. Discovery of nucleus was done by Rutherford. Discovery of nucleus in 1911. Okay, you must have to memorize these years as well, because in the board exam such type of the years will become in the MCQs or either in the short question, so you must memorize these years as well. Okay, so here it is the discovery of the nucleus which was done by Rutherford's experiment. So he performed an experiment, that is he performed it by bombarded a very thin gold foil with through an diagram. So here we will talk about an atom, and this is the small nucleus there of particles. How he performed that? He observed that most particles went straight through without deflection. Means these particles, as I shown you through this diagram, these particles are passed straight without any deflection. What is the meaning of that? Space, there must be an empty space there, so that's why the particles go straight without any deflection. So he observed a few particles deflected at larger angles, like that these are the these show deflection. Okay, when these particles are come near to the nucleus, they deflect it at a very larger angle, and some bombarded backside. So through this diagram, it is very clearly shown that some particles go straight without deflection, some particles are deflected at a very larger angle, and some are bounced back. Bounce back means they will move backside. After collide with the nucleus, they move towards the backside. So through these observations, he concluded there is a tiny, dense, positively charged region in the center. As you know that when the particles pass through the center like that, okay, I will show you. This is the nucleus. So as the particles collide with the center, it bounced back the particle, which means that there must be a positively charged region in the center of the region. So he called the center of the region as nucleus. So this is the nucleus. So here he discovered the nucleus. Protons and neutrons are reside inside the nucleus by the strong neutron. Both are reside inside the nucleus while the electrons are revolving around the nucleus. So I think this concept is very clear to you. And now if you have any question related to Rutherford's atomic model, you must question in the chat, so I will answer your questions. Okay, students, if you find any difficulty in that, then you will question so that I answered all your questions, right? So there is no question yet. So move towards the other topic, that is the Bohr's atomic model. Okay. So now move towards the Bohr's atomic model. Okay, Chi. Next, Bohr's atomic model. So it is the Bohr's atomic model. His full name is Niels Bohr. Niels Bohr in 1913. So these years are very much important to memorize because there must be the short question or MCQs related to Bohr's atomic model. So what he discovered? He discovered about he tell about the fixed energy orbits. He talk about fixed energy orbits. Okay. So I will show you this through diagram. This is a nucleus, and these are the orbits. Okay. These are orbits or shells. Orbits, and this is the nucleus. And here is the proton and neutron inside the nucleus. Okay, Jim. Now move towards what Bohr's atomic model is. Electrons revolve called the orbits. So these are the specific paths. Here to show these are some specific paths where electrons revolve continuously. Energy, because he talk about the fixed energy orbits. So these are the fixed energy orbits where the electrons are continuously moving in their fixed energy. If the electrons are present in the first orbit, then their energy is fixed. If they are moving towards the second orbit, their energy is fixed. If they are moving in the third orbit, their energy is fixed. So different energy levels are available, and the electrons are revolving around their fixed path. Okay. So now we talk about where the energy will be maximum and where will be the minimum. There's This is the nucleus, and the orbit that is very near to the nucleus has minimum energy. Minimum energy means very less energy. See, so there has minimum energy over there. And the nucleus, which is very much far away from the nucleus, that has the maximum energy. So it has maximum energy. Okay. Closest shell to the nucleus has minimum energy, that is called the ground state, and that is away from the nucleus has the maximum energy. Now we talk about their energy levels. So what are their energy levels? We talk about energy levels first. Okay. Energy levels, there are basically energy levels starting from shell, K shell, L shell, M shell and N shell. आप लोगों ने ये चीज़ें जो हैं वो बहुत ध्यान से सुननी हैं because there are many short questions regarding to Bohr's atomic model like that of shells and subshells. So you must have a concept about the shells and subshells. So K shell, L shell, M shell, and N shell. So if we talk about the K shell, what is their energy level? N represent the number of shell, one. If there is K shell, number of shell is one. If there is L shell, number of shell is two. Okay, and if M shell, number of shell is three. If the N shell, then the number will be the four. This is the fourth one. Okay, I will write it properly so that you may understand. Okay, this is the fourth one. So n shows the number of shells. Okay, it will be 1, 2, 3, 4, and so on. So here he talk about the shells as well as the subshells. So how much electrons will be the in K shell, L shell, M shell, and N shell? What do you know about? So please answer me in the chat. How many electrons will be the in K shell? Okay, I will write the question. How many electrons in K, L, M, and N shell? How many electrons in that shell? Answer in comments. Okay, answer in comments. So I will take your comments who know about that shells. So hurry up, please answer that quickly answered about how many number of electrons in shells. Okay, students, please answer quickly how many electrons in K shell, L shell, M shell, and N shell. Answer in comments, and then I will answer you. Please. So first of all, answer. First of all, I know what do you know about all that. I want to know who will answer me the first about the number of electrons in the shell. Yes, right answer. So now I will show you the exact number of electrons in K shell, L shell, and Mn shell through the formula. So here will be the formula. Here is the formula 2n square. This is the formula in which we know about the number of electrons present in the K, L, M, and N shell. Okay, so the value of N for K is 1, for L is 2, for M is 3, for N is 4. So we put all these values here in that formula 2n square. So now put it here and we will found 2n for K shell. 2 into 1 ka square is equal to 2. So total number of electrons in K shell is 2. For L shell, number of n is 2, so we put it 2 square is equal to 2 into 4 is equal to 8. Means total number of electrons in the L shell will be 8. Okay, so we talk about M shell, and M has the number of shell is 3, so we put 3 square. 2 into 2 into 9 is equal to 18. So total number of electrons in the M shell is 18. If we talk about N shell number of number of shell is 4. So we put here 2 into 4 square is equal to 2. 16 is equal to 32. So total number 32. So this for from that formula we know about the number of electrons, how many electrons in the shells present. So you did it, get my points? Yes. Okay, now move towards the subshells. These are subshells. Okay, so Here we go. Mhm. K shell, L shell, M shell, and N shell. Okay. So here, K shell, we will talk about the number of electrons is 2, number of electron is 8, and number of electron is um, eight- 18, 18, and N has number of electrons 32. So now we talk about the subshells. Here are the subshells. He divided the subshells into the four blocks, that is S, P, D, and F. So he considered all these four blocks, and now we put how many electrons will be there in the subshells. Okay, so we know that K shell has number of shell is 1, that is S. Okay, that is S. L has two shells, means there are two subshells S and P. Number of for M shell, the number of shell is 3. So there are three subshells S, P, D. And for N, the number of shell N is 4, means 4 subshells S, P, D, and F. Okay. So how many electrons will be there in S? There will be the 2 electrons. Here we see that the 2 electrons in the K shell, and it has the 1 subshell will be 2 here. So if we talk about L shell has 8, and it has basically 2 subshells S and P, 2 in the S shell, remaining total 8. S has 2, remaining 6, means 6 electrons will be the in P subshell. Now we talk about M shell. For M shell, there are 3 blocks S, P, and D, and the total number of electrons out that S has 2 electrons, P has 6 electrons, and the how many remaining 10 electrons will be the remaining. So rotated remaining 10 will be the in D subshell. Now we talk about S, P, D, and F. S has 2, P has 6, D has 10, and total electrons will be the 32. So here, how many remaining? 16. So 16 electrons will be reside in the F subshell. So these are the number of electrons in the subshells. So you must remember how many electrons will be the in subshells. So here we talk about all the number of electrons in shells and subshells as well. So I think it is all clear to you. Now next move towards another topic. Another topic is quantum theory of atom. So we move towards quantum theory of atom. Okay, I will write it here. Quantum theory of atom. So it is the modern probabilistic path concept. Means electrons are not tiny hard sphere; they are quantum particles. If we talk about the type of the sphere, how the orbit look like, so electrons are not a very tiny hard sphere. Their look is like that of the quantum particles. Quantum particles. We cannot map the exact 100% precise path of an electron around the nucleus. Okay, we can talk about there is 100% precise path. If we talk about accuracy, there is no 100% precise path of an electron that we find the electrons in the nucleus. So we cannot find the nucleus in a very exact precise and very accurately. Instead, we talk about the probability cloud. So we talk about, okay, we will find the electron. We will talk about, we will find an electron in a probability cloud. We will talk about probability cloud of finding an electron. So instead, we talk about the probability cloud of finding an electron. So an orbital, what is an orbital? So here is a question about orbit and orbital. What is orbit and what is an orbital? Here we talk about the orbit. The electrons are revolving around a uh, uh, fixed path called the orbit. And what is orbital? Orbital is a 3D space, three-dimensional space around the nucleus where the fine probability of finding an electron is maximum. That is the orbital. So there is a difference between the orbit and orbital. So these questions must be in the examination point of view. It is very important question to differentiate between orbit and orbital. So you must know what is orbit and what is orbital. So here we talk about orbit. Orbit has a fixed shape fixed shape where the electrons revolving, but orbital is a 3D sphere. Yeah, 3D finding an electron is maximum. So if we talk about the uncertainty principle, it is impossible to find the exact path or the speed of an electron at any given moment. So modern science views them as the clouds. So we talk about the probability clouds because we cannot find the nucleus more accurately and precising, and also we cannot find the speed of an electron at a given drive the fixed circular pathway orbits. But modern chemistry relies on orbitals because Bohr's atomic model only talks about the orbits. He not talk about where an electron reside. How can we find the electrons? So modern chemistry relies on orbitals, that is probability paths. Okay, I think it is clear to you. Must question me so that I may answer your questions. If you find it difficult in the Bohr's atomic model and Rutherford's atomic model or quantum theory of atom, that I have studied you far away. Okay, so if you have any questions, chat me so that I may answer your all the queries and questions. Then move towards the another topic, that is the atomic number and mass number. So have a break first. So 5 minute break will be there so that all the students may join. So here we will, okay, now move towards in, have a 10-minute break. So join me quickly. Okay, welcome back, students. Now we will talk about the atomic number and atomic number and mass number. So, what is atomic number and mass number? So, if we talk about a nucleus, we know that in a nucleus there reside inside the nucleus is only proton and neutron. And if we talk about the orbits, electrons are there outside the nucleus or will be revolving in the fixed orbits. So if we talk about only the number of protons, if we talk about only the number of protons, that is called the atomic number. It will also be called an proton number because here we only talk about the number of protons. So it is also called the proton number and it is represented by Z. So if we talk about mass number, mass number is the combination of proton and neutron. If we talk about proton plus neutron, that is the mass number. That is the mass number. It is also number because we talk about the whole we know that inside the nucleus both protons and neutrons reside, so we call it as the plus neutrons in the nucleus is the mass number and it is represented by A. So if we talk about how we write the number of protons and number of neutrons, so let us give you a general example. For example, if there is any element called an X, suppose, and we write the number of protons in the subscript and in the superscript, that is on the above side, above right side, we write here the mass number. See, I think it's clear. It is mass number and that is the atomic number or proton number. Okay, so I think this concept is clear to you. If you still feel there is question, so that I may answer you. Okay, so it's very easy, not very difficult to understand. Okay, now let's move towards the examples, how we write, how we can find out the number of protons and number of neutrons. So here we go. Carbon, for example, carbon, how many number of protons, that is 6, and number of neutrons is 12. How will we find out? Here we know that mass number is equal to number of protons, number of protons plus number of neutron. Okay, so this is the mass number. So number of proton in carbon is 6. Carbon is 6. Number of proton is also 6. 6 plus 6 is equal to 12. So mass number is 12. Got it? Now move towards the another example, which is that of we can say that oxygen. Oxygen has number of protons 8 and neutron number we can find out. So here we write mass number is equal to number of protons plus number of neutron. So number of proton is 8 and number of neutron is also 8. 8 plus 8 16. So we write 16 in the superscript of that. So 16 is the mass number of oxygen. I hope all that clear to you. If still find any difficulty, or you ask me about how to find out that protons and neutrons, so I may answer your all questions. Okay, so these are all about atomic number and mass number. So changing the number of electrons it forms an ion. Okay, for example, if we say that oxygen has the number of electrons uh, is that of 8, if we consider it as 9, means it gained one electron, so we write it O. Sorry, I will discuss it here. Okay, so if we change anything, for example, if we say about sodium, okay, this is the sodium, symbol is Na. If we talk about that, the sodium has maximum its atomic number is 11. If it has one electron lost, then the number of electron remaining is 10. So we can say that sodium get lost one electron and it forms an ion, that is Na positive, means it lost one electron. So if we talk about oxygen, oxygen has electrons. Oxygen has uh, activity. It alters the proton number, transforming the atom into a completely new number. Okay, when we talk about that, if the number of proton is changed, okay, so here we go about hydrogen. Okay, hydrogen 1, hydrogen 2, and that is hydrogen proton number 3. If changing in these proton number, here are some of the isotopes of hydrogen will become the radioactive. So radioactivity can alter the proton number and transforming the completely new element. Okay, so this is all about the mass number and proton number or atomic number. I gave you the simple trick how to find all that. Talk about A minus Z. Okay, so N is the neutron. Sorry. Okay, N is the neutron and A is the mass number and Z is the proton number. So it is the formula to find the number of neutrons. So if you have the proton number and mass number, you can find the number of neutrons. For example, there is an oxygen, number of proton is 8. So and the mass number is 16. So we put 16 here and 8 here. 16 minus 8 is equal to 8, so neutron is equal to 8. So if we talk about carbon, carbon has number of proton 6 and atomic number 6 and mass number is 12. So we put in that formula, n is equal to 12 minus 6 is equal to 6, means that the number of neutron in the carbon is 6. So here it is the simple trick where you can find the number of neutrons. So it's all about the lecture that I gave. I will show you today lecture at 8 p.m. Note it. So you will join me in my next lecture today at 8 p.m. So I will come and join you at 8 p.m. today. So we will talk about our new lecture and the new topics about that atomic structure. We will cover the topics of isotopes, radioactive isotopes, relative atomic mass, their formulas, and the important board exams questions. Okay, so we will cover all the points. If you have any queries or questions, you may ask, and I will answer you. Okay, so this is all about my lecture, and I hope you can understand very and you find it very easy. So see you in my next lecture, and stay happy, and bye bye.